We're going to be talking about reflection. So a reflection is a flip over a line. Okay, symmetry, or you can think of this as fold in half. Anyway, symmetry is where that line can be folded in half. And when you're talking about symmetry, you're talking about how many different ways could I fold it in half and it works out perfectly. So these are lines that show reflection of an image. So for instance, example 1 here. Determine the number of reflection lines or symmetry of the image. So if I'm looking at that arrow there, where can I draw a line in and it's going to cut it exactly in half? And I would have a horizontal line that technically should be going through the point there. So I'm sorry, I'm off a little bit. So we drew in the reflection line or the symmetry, so we have one symmetry line. On B, I have a couple there. I'm going to go through each edge. So this is considered 1, 2, 3, 4. Now this gets a little bit trickier. I'm going to switch colors here. I also have 5, 6, 7, and 8. So I have 8 total reflection lines there. What's hard about this, or what can kind of mess some people up, is they might count the line twice when going around the edge. So that's why I like to number them. That way I know, okay, this one line goes to the top as well, so I don't double count it. Just a little helpful hint. So, moving on. Now let's talk about reflections in the coordinate plane. So how do you reflect an image on the coordinate plane? If it's a reflection over the x-axis, this is going to sound kind of silly, but you will count number of units away, then go that many units above or below, depending on your picture. On the y-axis, it's the same thing, but you will go left or right instead. So nothing real fancy with this. It doesn't matter if it's the x-axis or the y-axis, to be honest. If you're dealing with any horizontal or vertical line, this is the same process. So one of the things that I always do is I always highlight what is my reflection line. Where is it? And the reason why is because I'm counting to that line. So if I'm doing the y-axis, I highlight it, and now I can count. So I can see here that L is 1 on the right of that orange line, so I need to go 1 on the left of that orange line. When you're dealing with your any transformation, don't forget to have that prime. So I've got L prime there. Looking at G, I am 3 to the right of G, so I need to be 3 to the left of G. So you're just going the opposite direction. Q here is 4 away, so I go 4 away from the line there. Now I connect it. It doesn't ask for the coordinates of G prime, L prime, and Q prime. You don't have to list them unless it states to state the new coordinates. Be sure to make sure, oh my goodness. Make sure you are reading everything that it's asking that you know whether you should include those coordinate points or not. So example 3, reflect over the x-axis. Again, I highlight the line I'm trying to reflect over, and now I just count. The x-axis, my L here is 1 above, so I need to go 1 below. The U is 5 above, I need to go 5 below. X is 5 above, so I need to go 5 below. You could have an image that is split, like that reflection line is splitting the image. So you just need to go the opposite direction. So if it says, if you are above, go below. If you're below, go above. It's all right if one goes the other direction. It's not a big deal. Just make sure that you're counting and going the opposite direction. This also, I know I don't have an example here. These also apply. Say for instance, I wanted to reflect this image over a line like this. You're still gonna count. So even though it's not the X or Y axis specifically, it's still a counting process. Okay, as a reminder, because this will come up, since I don't have this, I'm sorry, I should have thought of that. Y equals a number is horizontal, and X equals a number is vertical. Because you will have situations where it's not always x-axis or y-axis. You might have a vertical line or a horizontal line. That's obviously with a number. So just a quick reminder on that. Now, other reflection rules. Looks like I actually took care of this in example 4 and didn't realize it. Silly fish. Other reflection rules. So let's say you have a reflection in y equals x. So our original here is xy. This now goes to y comma x. Reflection in y equals negative x. When you have xy, this now flips. X becomes negative and y becomes negative. Oh, sorry, I actually have this backwards. So it is negative y comma x. Sorry, just thinking through. I still need my negative there. So for other vertical or horizontal lines, the easiest way to count boxes or fold paper, I just talked about that. All right, so next example, reflection line is y equals negative 1. Draw on my reflection line. Now I count. So I is one below, so I need to go 1 above. I should not be on a highlighter. E is 2 below, so I need to go 2 above. So I got I prime and E prime there. Q is 3 below, so I need to go 3 above. And I'm gonna say that's a V. Sorry, that's kind of hard to read, I get that. V is 1, 2, 3, 4 below, so I need to go 4 above. Now I connect. Move on. Y equals negative x. My reflection line you can also, so I know I have a rule there. You could also just look at this graphically and do it. Totally up to you. But let's list the coordinates. Make sure what I told you was correct. I normally just count it because I think it's easier for me to do it that way. So A is at 3, negative 1. S is at 1, 2, 3, 4, 2. T is at 5, negative 2. J is at 4, negative 3. So if I'm going through my prime information, I have A prime, S prime, T prime, j prime. Now, if I'm using that rule, I have x, y. If I'm reflecting over y equals negative x, then my coordinates here are going to become negative y, comma, negative x. So A is now positive 1, negative 3. And my rule does check out, so that's good. So S prime is now negative 2, negative 4. T prime is positive 2, negative 5. I should be marking my coordinates there with labels, sorry. And J prime is now positive 3, negative 4. And I connect. Again, you can still look at this as counting boxes. You're just on a diagonal. So A was one diagonal box away from the line. So I went one box on the other side. That's how I do it normally. I personally think it's faster because I don't have to list the coordinates. But some people struggle with finding that, and that's totally fine. So find the coordinates, use the rule. I'm okay with that. Now, we also have the last thing to talk about is a glide reflection. This is a combination. A glide is just translation. So you have a translation and a reflection. Does it matter the order? And the answer is no. You will get to the same spot regardless of if you do the translation first or if you do it second. So, last example here. Notice I have the translation rule and then I have the reflection over the x-axis. So you're going to actually end up with 3 triangles on here. The original, the translation, and then the final result with that reflection. So I'm going to go ahead and translate this. So I'm going 4 to the right and down 1. So we've got L prime, U prime, X prime. And then I'm reflecting it over the x-axis here. And I'm reflecting that green one. So now L prime is going to be the same as L double prime. My U, which kind of looks like a W, I'm sorry. Goes there, and my X double prime goes here. So I have all 3 triangles, and I know that the red one is my final result because it has the double prime. This is reflections in a nutshell. Again, you are just counting. Don't overthink this.